Hey guys and gals, how we doing? Welcome back to MR Academy for another math video. And today in this one we're going to be discussing prime and composite numbers. Last video we talked about multiples and factors. And we brought up the idea of a prime number. But a prime number, as we discussed, is a number that only has two factors, two numbers that multiply together to get that number, okay? 1 and itself. So for example, we have 13, which is only 1 and 13. 23 is a prime number. It only has 1 times 23. You can't multiply any other two whole numbers together to get that number, 23. And 151, okay? A really big number. You can only multiply 1 and 151 together to get 151. Nothing else, no other whole numbers multiply together to get that number 151. On the other hand, though, we have a word that we did not discuss last video, and that number, or that word, not that number, that word is composite right here in purple. Okay, a composite number is basically the opposite. That's every other type of number that you're going to find. Okay? A composite number is a number that has more than just those two factors. So a prime number only has 1 and itself as factors. A composite number has more than two. Okay, so for example, 36, the numbers that multiply together to get 36. And for some reason I didn't include 36 on here. Ignore that and, comma, 36. Okay, so 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, 9 times 4, 12 times 3, 18 times 2, 36 times 1. Composite. It's got a bunch of factors. It's got more than two. Okay, in fact, this one's got 1, 2, 3, 4, 5, 6, 7, 8, 9 factors total. Okay, that is more than two, last I checked. 72. We have 1 times 72, 2 times 36, 3 times 18, 4 times 12. Oh, that's not 4 times 12. Let's see. Sorry about that. By the time I'm recording this, I don't remember how many videos I recorded in a row. Let's try this again. 1 times 72 is 72. 2 times 36 is 72. 3 times 18 is not 72. We missed one in there. 24 should be in there. I thought I missed something. 3 times 24. There we go. 3 times 24 is 72. 4 times 18 is 72. 6 times 12 is 72. 8 times 9 is 72. And then we can go backwards as well. We can flip those numbers and say 9 times 8, 12 times 6, 18 times 4, 24 times 3, 36 times 2, 72 times 1. All multiply together to get 72. The point is, that's composite because there's a lot of numbers right there that you can multiply together to get to 72. Okay, so that is what we are looking at. Okay, does a number only have two factors? Does a number have a bunch of different factors? Okay, more than two of them. So let's take a look at these examples down here. Number 1, 4. Okay. Factors. Once again, we're talking numbers that are equal to or smaller than the number that we're working with. Okay, so which numbers multiply together to get 4? Well, this first line, we're going to write the factors, then we have to tell whether it's prime or composite. So, numbers we can multiply together to get 4. Well, 1 and 4, and 2 and 2. So 1, 2, and 4 are the numbers that we can multiply together in different ways to get 4. Is that more than 2? Yes, it is more than 2. 1, 2, and 4. We have more than just the number and itself. We have 2 thrown in there as well. So that tells me it is composite. And that's just a hard rule right there. Okay, if it has only 2, it's prime. If it has more than 2, it's composite. Simple as that. Okay, that's all you need to worry about. Number 2, number very similar to number 4, or to 2, 4. Okay, we have 1. 3 times 3 is 9, and then 9 itself, 1 times 9. Again, if it was just 1 and 9, it would be prime, but we have 3 thrown in there. So that does make it a composite number. Going down here to number 3, 7. To my knowledge, there are only two numbers you can multiply together to get 7, and that is 1 and 7. That is all, which tells me It is one of these numbers right up here. It is a prime number. We only have 1 and itself as the factors. So prime for 7. And then 27. Okay, it looks like one of those weird numbers, but we know 1. But 3 you can also multiply by 9 to get 27. And then 27, of course, is itself a factor. And it looks like we do have more than 2, so that number 27 is, in fact, composite, because it has more than just the 2 factors. All right, let's take a look at a couple word problems here. Now we have a little bit of extra space here because we're going to do a little bit of drawing. Okay, so we want to arrange a bulletin board that has equal rows and columns for 32 drawings. Okay, so we're going to have 32 pictures total on that bulletin board. And we need to figure out if 32 is a prime number or a composite number. And we're going to list all the ways that we can present that bulletin board. Okay. Well, just thinking about it, what numbers can I multiply together to get 32? I can say 1 times 32, and I can have one really super long row, and I can draw it out like that. Okay, 1 times 32, 1 and 32. Okay, just imagine these are all boxes. Okay, it would take a long time to draw 32 boxes. We're not going to draw all 32, but just imagine 1 by 32. So we can make a really long bulletin board that's got 32 drawings in one row. We could also say, okay, well, we could say we could have 2 rows that have 16 in each one. That would be 32. So we could have 16 drawings in each of 2 rows. That would be good. Okay. Then we could say, is there another way that we could do this? We could do 4. We could say, all right, there are 4 rows. Yeah, let's make these lines just a little bit longer. There we go. Trying to make them half as long as the 16 up there. So we could have 4 rows of 8. That would be good. That would equal 32. And then we could just go the other direction. Okay, we could say, all right, 8 rows that have 4. We could say 16 rows that only have 2 drawings. And then we could say 32 rows that have 1 drawing in each one. Okay. So we have figured out that 32 is, in fact, well, it's got more than just 2 factors to it. It's got 1, 2, 3, 4, 5, 6 different factors. It is, in fact, composite. And we're going to write that up here first. And then we need to write out the ways that we know that it is composite. Well, we can make a 1 by 32. We can make a 2 by 16. We could make a 4 by 8. We could also flip the numbers around. We can make an 8 by 4. We could make a 16 by 2. And we can make a 32 by 1. Okay, all those different ways that we could arrange that bulletin board. We could have 1 row of 32 drawings. We could have 2 rows of 16 drawings, 4 rows of 8, 8 rows of 4, 16 of 2, or 13 rows of just 1 drawing in each. Okay. So that tells me, yep, that is definitely a composite number right there. Okay. Similar type problem down here. We have, they're asking us to arrange our bookshelf with equal books in each row for a stack of 49 books. Okay. Decide if 49 is a prime or composite number. And we need to figure out a way to list all of the ways to present the books. Well, we could say, okay, one really long shelf that's got 49 books. That would be really, really awkward, but we could do that. We could also say, okay, we could have 49 shelves that each have 1 book. Again, very, very awkward, but it would work. But there is a number that would also work that makes this number a composite. And what number is that makes 49 a composite number? Which factor makes 49 a composite? 7. Okay. We'll cross that off. We need a 1 by 49. 7 by 7 is what makes this a composite number. Boy, there we go. We'll get rid of that. And 49 by 1. There we go. Okay, that 7 by 7 is what makes this number composite rather than prime. Okay, if we just had 1 by 49 and 49 by 1, that would be prime. But 7 by 7 also multiplies to get 49. Okay, that makes this a composite number. And then we would have a square number right there. That's kind of a square. Okay, so we would have 7 rows and 7 rows. Let's try to do that. 1, 2, 3, 4, 5, 6, which gives me 7 rows. We'll do the same thing up and down. Oh boy, that was horrible. 2, 3, 4, 5, 6. Yeah, that first line was terrible, but we made it work. So there's our shelf right there. We got 7 by 7. We could draw it out 1 by 49, 49 by 1. We'd be here a while. So we're not going to draw that out. But we do know it's composite, and those are the 3 ways that we could present the books. Okay, 1 by 49, 7 by 7, or 49 by 1. All right, so just a brief video. Okay, not much to that one. That is prime, that is composite. Prime numbers have only 2 factors, the number and 1. Okay, so 1 and itself, whatever that number happens to be, 13, 23, 151. A composite number has more than 2 factors. 36 has a whole bunch, 72 has a whole bunch, 24 has a whole bunch. Okay, 40 has a lot. Many, many, many different composite numbers. Okay, it could be something like 49 as well. It's only got 3 factors, but that is more than 2. Okay, it's got 1, 7, 49. Okay. That's all prime and composite numbers are. Again, we'll discuss that later on. Prime and composite will come back once we start talking about greatest common factors, least common multiples, that kind of stuff. That'll be a long way down the road, but just a nice little introduction, if you will, to prime and composite numbers. Hopefully this made sense. Hopefully this helped you out. If it did help you out, do me a favor, hit that like button. Drop a comment. Let me know that these videos are helping you and that they're making sense to you. And if you are enjoying them, if you are getting some help from these videos, hit that subscribe button. Ring that bell. Let me know by doing so that you are getting help from these videos. That is my goal, to try to help each and every one of you watching these videos to understand math just a little bit better than you did before. Try to make math easier for you. Yeah. But thank you for watching. I hope you have a great rest of your morning, great rest of your afternoon, great rest of your evening, whenever you happen to be watching this. And I hope everyone watching will, until next time, take care.